All right, let's look at the expected value of exponential distribution. All right, so let's compute that. So expected value would be, so we need to integrate. So in this case, expected exponential distribution is defined on from the 0 to infinity. So we put 0 here and infinity here. Then we have x times f of x, which is 1 over lambda. Actually, can I write it as x over lambda? All right, that looks a little bit better. And then you have e to the negative x over lambda with respect to x. Right? We're going to have to use the integration by parts. So let's go through that. All right, so I'm going to let this guy to be u, and then this guy to be dv. All right, so let's do that. So we're gonna let, maybe I'm gonna go up here, maybe here. Let u be x over lambda, and dv to be e to the negative x over lambda dx. All right, so we need to take the derivative. So you have a du over dx is simply 1 over lambda. So if you want du is simply dx over lambda. All right. All right, then here I'm going to just divide through by dx. Maybe I'll just write that, divide through by dx. So you have a dv is equal to dx, which is just a derivative of v, e to the negative x over lambda. All right, then if you want to find just a v, we can just integrate. So if you integrate that, antiderivative of that is, let's see, so write down e to the negative x over lambda. Derivative of that is negative 1 over lambda. So you divide by negative 1 over lambda is same thing as multiply by negative lambda. All right, so we have that. All right, so we're going to need u du and the v to go through the integration by parts. All right, so let's do that. So this is going to be, right, so uv, right, so it's going to be, so this time, so actually lambda cancel out. So you have a negative x e to the negative x over lambda. Right, so I'm going to kind of cheat a little bit, or being lazy. I'm going to go from 0 to infinity instead of replacing with a b and to take the limit. And we all know what this means, so I'm going to just write it that way. All right, so minus, right? So you have a v du. So there's a negative sign, so I'm going to turn it into plus sign. Then you have an integral from 0 to infinity, right? Then, so lambda cancel out, so you're just going to get e to the negative x over lambda dx. Right. Then here, so we are taking a limit, so you plug in x, right? So this might be a little bit tricky, so you basically have x over, or actually negative x over, so negative power, so e to the x over lambda. All right, so maybe I should do it separately here. So if you want to take the limit, for example, of, so you have a negative x over e to the x over lambda. this is the same thing, right? Because it has a negative power, so I put it on the bottom. And then x is going to infinity, right? So we can use a L'Hopital's rule since the numerator goes to negative infinity and the denominator goes to, in this case, positive infinity. So we can use L'Hopital's rule. So applying L'Hopital's rule here, then you have a limit as x approaches infinity. If you take the derivative of negative x, it's going to be negative 1. If you take the derivative of that, you have e to the x over lambda, and then multiply by 1 over lambda, to just a chain rule. And you can see that here, as x approaches infinity, this guy goes to infinity, which means that you are dividing negative 1 by a really, really big number, so it's going to approach 0. So you can see that as x approaches infinity, this quantity is going to approach 0. So you have a 0 minus, then you have a negative sign plus. If you plug in 0, it's going to be 0 because 0 times anything is 0. So this whole thing is going to approach 0. So this whole thing is going to go to 0. So we can kind of ignore that. Then plus. Then you take the entire of this guy, so you have e to the negative x over lambda, negative lambda. And then you're going from 0 to infinity, So this is going to be, so if you let x go to infinity, e to the negative infinity goes to 0, so it's going to be 0, minus, and there's a negative sign, it's going to be plus. If you plug in 0, e to the 0 is 1, so you have a lambda, so you have just a lambda. So this is just going to be lambda, So expected value of exponential distribution is actually lambda. So it's actually pretty easy to remember. So therefore, mu is equal to lambda. That's it. I hope that this was clear.